hello everybody. Again, my name is Kevin Knapp, and we're going to be covering the clap library. This talk's called Rust Utilities. It's about building command line interfaces and command line applications in Rust. So this talk, pretty much what I plan to cover is a little bit of why Rust, a little bit about command line utilities in general, and specifically about building the interfaces using clap in Rust. I don't really plan to talk too much about Rust basics. This talk does not at all go very in depth. If you just have a very basic working knowledge, that's more than enough. But I don't expect that you've never ever seen Rust. I expect you've at least seen a little bit. I'm not going to talk too much about CLI user experience. That's a whole other topic in and of itself. I like talking about it, but in this talk it's not going to include much of that. Also not things like environmental variables or configuration files, because those can get pretty involved and just purely for time considerations. So who am I? Like I said, Kevin Knapp. I'm a systems and network admin by trade. Big skydiver. Back about 10 years ago or so, I was a .NET programmer, primarily C#. Moved on to Python. Python is probably what I use the most during my day job. Eventually moved on to Go because of different performance and deterministic reasons, but was left a little bit less than satisfied, which left me looking for Rust. I found Rust probably in around the 0.9 days, somewhere in that time frame. Got hooked on it and have been kind of playing around with it ever since. So I get to use that a little bit at my day job. So right now it's pretty much Rust and Python. We're going to call this Rusty. He's going to be our reminder and symbol for this project. And just remember that there's always more than one way to skin a cat. All jokes aside. All right, so a little bit about command line utilities in general. I'm not going to spend too much time on this. I'm going to breeze through most of these, and I might even skip a few slides purely for time. If you break down all major command line utilities, you can break them down into these few components: the controller, or sort of your main method, your main file. You've got your interface, a configuration struct, or a God object sometimes. You have your actual application that does the actual work. You might have some utility structs or utility functions off to the side, and then very importantly, you also have your output and your errors. These are probably some of the most overlooked things. Potentially the errors are the most. Something I've found very, very, very helpful is to look at some of the good code out there, particularly by Burnt Sushi is a really good model to look after some of his work, specifically like RipRep is amazing, and digging into how that's broken out. One of the nice things about Rust, it makes it very easy to modularize these components and really pull out everything that's your application into separate crates or modules or functions for reuse later on, which kind of leaves you with just your configuration and interface to handle the actual utility portion. So if we were to take a high-level look, it would look something like this. If you've got your main function, which is your starting point, for that point, you might build your interface, show that to the user, or the user might talk to that. That will then get normalized into some form of configuration struct or args struct or God object, something that says how your application is going to run, and then that'll usually get handed off to the actual application itself. Something that all these applications do is, or a lot of the rustic applications, is they'll use the result types and bubble their errors back up to the main function for display and output. So we're going to kind of skip a few of the next slides that kind of dig into each one of those, just purely for time. And we're going to move on to the interface, because that's the meat and potatoes of what I'm going to talk about tonight. If you're curious, you can go on through these slides and see just a few options or a few bullet points about each of these different points. So command line interfaces in Rust using clap. Because I'm terrible at naming things, I named it an acronym, command line argument parser. The 5-second pitch is simple to use, efficient, full-featured library for parsing command line arguments and subcommands when writing console and terminal applications in Rust. You can think of it as encoding a type system into your arguments. or letting clap do a lot of the validation for you so that you don't have to. So we're going to start with the basics. This GIF actually has absolutely nothing to do with the basics. I just like it, especially from Rust Belt Rust. So to get started, obviously you need to add clap to your dependencies array. As of right now, the latest version is 2.20.4. I always recommend using at least 2 or 2.20, something along those lines, and not just star. Especially right now, because as of the time of this talk, which would be, I don't even know what day it is, February 16th, 3.0 is probably pretty close on the horizon. And if you just use star and you accidentally pull in a 3.0 and your application breaks, well, then that would be bad. So after you've added it to your dependencies array, you then pull it in through your extern crate in your top level file. There's a few key players in clap. So when I set up to design clap, one of the key things that I wanted to get away from was having a bunch of different structs that people had to memorize and know what they do and how they interact and figure it all out before they even started using it. So I wanted to have an application struct and an argument struct. Just keep it really simple. And I guess eventually added on the matches struct and the subcommands. The way it works, though, and we're going to talk about each of these in turn, is we use the builder pattern throughout clap pervasively. So if you're not familiar with that, there's a link right there, and it's a talk written by Aaron Turon that explains the builder pattern pretty nicely. But we use that. You've got your app struct, which will sort of sets like an abstract representation of your application as a whole or as of a particular command. And then you have your argument structs, which you can add to this application and tell the application how exactly you want to accept these arguments. Once you're done with all that, you can request back a matches struct, which will go through and parse everything the user does and give you back the normalized matches to that. And then finally, you have subcommands, which are really just sub-apps. We're going to get into all this. So the builder pattern allows you to use a large number of optional configuration without having to have a whole bunch of different constructors or memorize all of the fields and list everything out when you only want to use 2 or 3 of them. You'll see this time and time again as we go through some of these slides. Most builders are one of 2 types. They're either consuming or non-consuming, meaning the builder object. Usually it's called something like something builder. In Clap's case, it's just called app instead of app builder, and that's just for simplicity's sake. But usually what they'll do, either consuming or non-consuming, is you'll have one final method, a terminal method, or maybe a family of methods that do something with that builder. They either convert it to something or do some action with it and give you something back. Clap uses a consuming builder by default, meaning it'll take this application struct, it'll consume it, and it'll be deallocated. But there's ways to keep it from doing that as well. So it's not necessarily purely just a consuming builder. So we've got our app struct. And if you're going through these on your own, all of these up here, these are all links. And they're links to the documentation or to other places. So you have your app struct. Like I said, that's an abstract representation of your application itself. It can contain things like metadata, such as things like your author or version information, little descriptions. And then it'll collect up all of your arguments and subcommands. And it will do a few things. It'll first create a help message for you automatically based off of all of the arguments you've supplied. And it'll also parse all of the user input and return back the matches. So this right here, I'm going to use the mouse pointer for the sake of the recording instead of something like my finger or a laser pointer. But you create your app struct, and then you set various properties on it. Finally, you'll call the get matches, and which will be the terminal method to this. If you were to do something just this simple right here, setting an author, a version, and a small description, what that'll at least give you is the ability to have a -v and -- version and a -h and -- help generated for you automatically. So with, I don't know, 4 or 5 lines of code, you already get something that helps out quite a bit. So one of the first things I do when I use any command line application is, do -- help just to see what arguments are out there, and having that pop up is usually pretty helpful. Any of these run online links, It'll take you to the Rust playground, but it's the integer 32 playground, which allows you to use external crates. The only difference here is instead of the code snippets that you'll see throughout the talk, I've changed them over to get matches from, which allows you to supply your own sort of argv that you're going to match from instead of what Rust uses by default, which is the environment. So here, it's just as if we passed in our program name and then dash dash help. And if we were to run that, this is what would be displayed. Program name, version, about, and some of the valid arguments. So then you've got your arg struct. This was the most important part of it. One of the hardest things about some of the other argument parsing libraries were that you had to memorize all the different struct types, opt arg, flag arg, all the, I can't even think of all of them right now, free arg. With this, there's just a single arg struct. Depending on which builder methods you set will determine how the argument behaves, which means you can also change the way an argument behaves by simply adding or deleting a line here or there, which makes it pretty handy to test out different arguments. In clap, there's 3 different argument types. They all use the arg struct, and behind the scenes they're using actual types. But as far as the user is concerned, it just looks like a single arg struct. Those different types are flags, which are the ones that use a hyphen, either a single or a double hyphen, but have no associated value. You also have options, which have a single or double hyphen and an associated value, one or more values. And then you have positional or free arguments, which are index-based and have no, dash or dash dash before them. So this is what it looks like to use some of the args. You can set a help, you can set a short. Some of these methods have some convenience ports to them. You don't have to put the dash F. You can, it'll just strip the dash. Down on the second one, notice we put takes value true. That turns it from a flag into an option because we're expecting a value to be associated with it. And down at the bottom, we have just a free arg. There's no short or long associated with it, and it doesn't take a value. And if we were to run the dash dash help with this one, you would see those different help messages displayed alongside the argument. So you can add args to your application struct either one at a time or in clusters. There's a very, very slight performance difference in these two. The adding them one at a time is slightly faster, and by faster I mean like nanoseconds faster. It's not really a measurable amount of time, but just so you know. All right, so now that you can define all these different arguments, what can you actually do with them? Once you've defined all the different arguments for your application, and you call the terminal method get matches or any of the others, get matches from, get matches safe, any of those, you can do a few things with the argmatches struct. You can either get values back from the associated argument. You can get how many times that argument was used, because if it's an argument that it can be used more than once, you can find out how many times it was used. You can also find out whether or not an argument of subcommand was used at all, just with the is present. With the numbers of occurrences, one particular note, and we'll see this in a little bit, is it's not counting the number of values, it's counting the number of times the actual argument itself was used. So if you have an argument that accepts 2 values for some complicated case, and that was used twice, meaning there's 4 values, the number of occurrences will give you 2. The argument was used twice, even though there happens to be 2 values associated with each one. So just things to think about. So out of the few examples we've seen already, we've already seen short, long, help. We've seen index, kind of, and takes value. What these actually do is the short gives it your single hyphen value, or your single hyphen accessor, which are also stackable. If you have multiple arguments that have a single hyphen accessor or a short, they can be stacked. So for example, the -x fzd is the exact same as supplying the -x, -f, -z, -d all together. You have a long, which is the double hyphen accessor, a help, which displays a help message. I'm going to skip index for just a second, and then takes value, which associates a value. There's multiple different ways to give the value to that particular argument when you're calling it at runtime, and clap supports all of them, whether it be with an equal sign, with a space, or if you're using just the short, the single dash, there can be no space at all. This can also be combined with other stackable values where dash xfs val, dash s is the short and val is the value associated with it. All of those are supported by default. There's nothing you need to do. So back up to index. If you saw on the previous few slides when we did a positional or free argument, we actually didn't specify an index. That's because they're inferred if you don't manually put it in there. And they're inferred lazily in a first come, first served basis. They start at 1 because typically your program itself is 0 and the actual index for your positional argument starts at 1. The key thing to note here is that the positional arguments, that's the index of positional arguments, not of arguments in general. So for example, if you had 5 options, 2 flags, and 1 positional argument, and it happens to be at the end, it's still going to be index 1 because it's the first positional argument. The reason that you're allowed to specify an index is if for whatever reason you're dynamically generating your arguments and you know for whatever weird reason index number 3 is generated first, you can tell it, hey, this is actually the 3rd positional argument. It just lets you specify them out of order if you need to. There's a few other methods for the arg struct that are somewhat basic and used pretty pervasively. Things like required, where you can say that the argument must be used. Otherwise, clap will give an error and tell you that it needs to be used. A default value for if the user didn't specify something, but you want a value to be associated with it anyways. And multiple. With multiple in particular, if all you do is specify multiple true, you're saying 2 things. You're saying, 1, this argument can be used multiple times. Imagine you have like a verbose flag where you want different levels of verbosity, you know, VVV or VV. If you associate a value with it, takes value true and multiple true, you're also saying it can accept multiple values. So you could say, you know, dash dash config with 5 files with it. Now there's ways to limit that, but by default, if all you do is say multiple true and takes value true, you're saying not only can this argument be used multiple times, but it can also have multiple values associated with it. So that's one thing that I think in 3x we might try and clean up just a little bit because it gets confusing sometimes for users. There's ways I said you can pare that down and tell it, no, I only want 2 values, or you know, I only want to be able to be used once by multiple values. There's ways to do that. It's just that is a point of confusion every once in a while.
Common use for wanting multiple arguments,
multiple values?
Oh, yeah.
Multiple values is less common than having multiple occurrences. Multiple values, I think I've only seen them with people writing like IRC, either, I don't know, servers, or where they want to be able to specify, I can't think of one off the top of my head, but it's usually like an input and output, and they'll have like dash dash stuff, and it's, you know, 2 different values associated with, because maybe it's a pair. There is an example later on that we'll see in the slide where you can use multiple values to your advantage to make it look like a single value, and there's times where that comes in handy. You'll actually see that in just a few minutes. Multiple occurrences is far more common, and in fact, one of the best practices that I would say is if you want to accept multiple values, set it so that you can have multiple occurrences. You know, an option can appear multiple times, but only 1 value at a time. And that's much easier to read for things like documentation. If you're telling your user how to use it, it's much easier to say like, hey, dash O, this value, and then do dash O again, this value again, rather than dash O, value, value. So subcommands are one of the biggest things that a lot of people would come to clap to use because they're handled decently well. But you need to wrap your head around the way that they're structured. So subcommands are actually just sub-apps. That's literally all they are. They're built with the subcommand : new, but that's literally where that stops. It just returns back an app, which means they can contain all the same metadata, same arguments, their own subcommands, everything, just like a regular app could. One of the byproducts of this is that means you can have a subcommand that's developed as an entirely separate application and have separate versions, separate authors, everything. But so long as you remember that they're just sub-apps, that's really it. So subcommands are actually or apps in general are set up in sort of a recursive tree-like structure where you can only access one per level at a time. So if you imagine a fictional Git, this isn't necessarily how Git is actually structured. It's just a good example. If you had your top level application called Git and you added 4 subcommands to that, clone, push, add, and commit, each of those contained various subcommands. Maybe clone had URL, push had origin and remote, and then some of those had subcommands as well. So here ref has 2 subcommands, remote and local. Valid invocations of this entire tree would be git clone URL, git push origin path, where you're only going one layer at a time and you're just following the tree down. You can't hop over to another branch. Where that comes into play is when you start requesting matches back for subcommands. If you remember that only one subcommand can ever happen at a time from that one particular layer or level, then you can just traverse that tree on down. So you start off with, you build that top level application Git. We're eliding some of that. And then you request the subcommand. When you request the subcommand from clap, you'll get back the name of the subcommand and any associated matches. So for example, if the user used the push command, you'll get back the push matches, which contain all of the arguments that push defined, as well as any subcommands that push defined as well. So from this level, we can then request push's subcommand, which maybe they used remote or local, and we get the associated matches for that. What this means is it's not one flat structure. From this top level Git, let's say for example remote contained an argument URL, right? --URL. We couldn't, for example, say from Git, give me the value for --URL because it doesn't know of that. You would actually have to go down this tree to remote's matches. Remote knows about URL. Now there are ways to have global arguments. You can absolutely have global arguments, but that's a slightly more advanced way. This looks kind of messy at first, but it allows you to separate concerns very nicely into different modules, different functions, and really only worry about what that one subcommand is and what you're worried about with that one level. So if we get, that's all of the basics. If we get into the intermediate level of clap, or what I was more like customizing the arguments a little bit more heavily and getting into some of the actual benefits of using clap, one of the number one things is argument relationships. You can define, and this is more or less the quote unquote like type system for your arguments. You can define that arguments have different relationships with other arguments, such as they can either have hard conflicts or soft conflicts, where a hard conflict would be these 2 arguments can't be used together and clap will spit out an error if they do. Or you can define soft conflicts, which is more like a POSIX style override, where if these 2 arguments are used at the same time, whichever one was used last, quote unquote, wins. An example of that would be if you want to support things like aliases in a Unix command, someone could alias 2 flags that are conflicting, but when they run the command at runtime, that one flag that's conflicting that they actually ran would be the last command to be used, and therefore it would win over the conflicting argument. So you can define things like that. You can also say that if a particular argument is used, it also requires the use of these other arguments as well. You can also customize values, and the way values are either presented to the user in help messages or the way that they behave. Some of the ways that you can specify the way they behave is you can say that only these particular values can be used, such as the possible values method right here. You can say only this list of values could be used for this argument. You can say things like empty values are or are not allowed. By default, empty values are not allowed, but you could have an option which also accepts 0 values. You can also change the value name, which is more or less just for the help message. By default, if you don't specify a value name, clap will use the argument's name itself as the portion between the angled or square brackets, which can get confusing sometimes and just looks a little bit less nice. It's much nicer to have something like, hey, if I'm going to expect a bunch of paths or a bunch of files, put path or file rather than config file, config path, you know, all these different things down the line. You can also specify things like allowing values that accept hyphens. Where that would come into play is if you want to support something like negative numbers as a value. by default, the way that clap determines if you're looking for the next value or the next argument, it looks to see if it starts with a hyphen as a simple kind of heuristic. Sometimes that falls down, though. If you're trying to support a command line interface where you want to accept a bunch of commands and pass that off to another command, that other command may very well have valid flags that you don't want clap to try and interpret as its own. So you can say, hey, some of these values start with hyphens, and that will only apply to that one particular argument.
Does it have support for the double hyphen escape standard?
Yes, and actually I forgot to list that in this talk, but yes, it does support the double hyphen, which means after the double hyphen, everything else is interpreted as positional arguments. So, and at that point, yes, you could also use hyphens as well, because it just stops interpreting. You can also customize multiple values. So before, when I said that you can accept multiple values for a single argument, not necessarily multiple occurrences, but multiple values, you can do things like require a delimiter, such by default it's a comma to separate out values, a comma or a space really. But if a user uses dash dash config some value, comma, another value, to clap that's interpreted as two values by default. You can set that to either require the use of a delimiter or not. You can also turn on or change that character to something other than a comma. You can also specify things like a terminator. So you can say this particular argument accepts at least at least two values, and stop parsing when you reach this particular character. Maybe a semicolon or something like that. You can say stop parsing at this point and go back to your normal parsing. Or stop parsing values, rather.
Sorry, when you say the delimiter can be turned off entirely, does that mean?
That means if you don't want a delimiter, so let's say you want something with a bunch of commas to be interpreted as just a single value, you could say don't use a delimiter at all. In which case, value comma one, value one comma, value two comma would all be interpreted as one single value.
So if you turn off the delimiter, how would you distinguish distinct values from plural?
That would be up to the consuming application to determine. So I've seen this before where they want to, again, this was an IRC thing, where they wanted to support, it was like -x, v, and they wanted that to all be one value. So they wanted to turn off the delimiter, and they're like, we'll handle the commas ourselves because we have something else that we do with them, or it means something to us. I forget what it was. But they just turned it off entirely because they also weren't sure about picking another character. They're like, that may conflict with something else we want to use later on. So, but yeah, in this example right here, where you have a application calling it do, and then we have a single argument, which is a positional argument, because it doesn't have any long or short. We're saying it accepts multiple values, it allows hyphen values, and stop parsing this particular argument, go on to your regular parsing once you reach a colon. And then we have another positional argument, which would be index 2 of a location. If you run it like this, do find -typef -name special, this, and then /clap. If you were to check the values of these two, the values of your commands argument would be find typef name special colon. The value of your location would be /clap, just showing that it stops parsing once it reaches that terminator. You also have a thing called validators, and this is the other key piece of letting clap do the validation for you, or somewhat, because you're kind of defining the function. You can have a particular function or a closure run on every single value of a particular argument if you need to. For example, this one runs let's see if the input file starts with or ends with a PNG. If not, it'll return back an error. The way validators work is it accepts a string as which is the input value, and you just need to return a string back with the error case of the result enum in order for the error message for the user. There's also an OS string version if you're handling stuff that does with invalid UTF-8. But this is where you can have a particular function run on every single value for whatever case. So if we put those few things together, this is what I was talking about with the multiple values. This is a sort of a contrived example, but it demonstrates some of those things that we've previously talked about. So if you wanted to validate, let's say, an IPv4 address without taking into account that there are invalid numbers for certain octets, if you just wanted to validate that each one of the numbers was used and each one of them was between 0 and 255, you could do something like this. Come up with a new application named net and a single argument. We're calling it IP. It has a short of I and a long of IP address or IP adder. We're giving it a value name because this is how we want it to appear to users instead of IP adder or IP. That's just a help message. We're saying it has to be used. We're saying it contains 4 values. So IP address can only be used once, but it has 4 values. We're telling it to use the valid octet whenever it encounters a value. Use the delimiter dot, and we must use a delimiter. So if we were to run this, it's going to run a validator on each one of the octets, which is just going to see if it's a valid U8. If not, return this error. So if we go over to here real quick, I have some different error cases set up, but by default, if you just say -I, 10, 20, 30, 10, it says, yep, it's probably a valid IP. There we go. All right. If we were to do something like this, it should give us an error. Here, because 500 is outside 255. Same valid value, 500 is outside of it. But that's just showing, putting a few of those different things together. Now, this is also somewhat verbose. Well, not somewhat, it is verbose. There's a lot of lines right here. This can actually be shortened up. There's a bunch of other methods of clap that we're not really going to talk about, but I'd be happy to discuss offline. Where you can turn these, 10 lines into probably 2 or 3. So there's some far less verbose ways to specify all of that. Oh, I think I actually went down. All right, so once we've, now that you know how to customize arguments and their values, the probably second most important aspect is customizing the application struct itself. There's an enum called AppSettings with 30 plus settings. Each one of these settings subtly changes the way the application struct does its parsing, does its displaying, everything. A lot of these let you really customize how you want to use your application. If you look at the AppSettings struct, there's a ton of them. But I would highly recommend, if you do start using clap, this is something that's very much worth looking at, because a lot of these things are, a lot of people use quite a few of them. And they let you do things like saying whether or not a subcommand is required, whether or not a subcommand is hidden. And because a subcommand is really just an app, you can set these on any one of your subcommands as well. You can do things like hiding those possible values within help messages. There's all kinds of different things you can do. But it's highly worth at least checking out to see if any of these might apply to your particular situation. We can also set settings globally, meaning it's going to apply not only to this command, but also to every child subcommand as well. Probably some of the most notable app settings that you could encounter are leading hyphen, which we've kind of spoken about, but this does it application-wide and not just for a single argument. Derived display order. By default, clap displays, if you have a whole bunch of arguments that you're displaying in a help message, it'll display them in alphabetical order. For some reason, if you don't want to do that, because maybe 3 of your arguments are very important, you want them to be up at the top of your help message, you can say derive the display order, and that way clap will display them in the order in which you define them. You can also say whether subcommands are hidden or applications are hidden. You can say things like the subcommand or argument must be used, otherwise display the help message instead of just an error. You can also do this thing called unify the help message. If you're familiar with things like docopt, what clap calls flags and options, docopt just calls options. And a lot of people like that those two things are combined. So you can do this. If you specify this, clap will combine those two, and it'll display them in the same way that docopt does. These two settings right here are automatically applied globally. Just FYI. Versionless subcommand says your subcommands don't have versions, and they don't have the -v and -- version argument by default. Global version says just use whatever version I use for my parent application. And that's what a lot of people do, because that's probably the most common thing. You can also customize the help output with either a before and after message, or if you don't like the way it's structured at all, you can re-customize it entirely with the template. If you use a template, you can put this in you can put them in any order. There's all of these different tags that you can use, and basically spell out your template for clap, and it'll paste it in there however you've specified. It's a homegrown solution. Yeah, it's one, I'm going to pronounce his name totally wrong, so I'd have to pull up the GitHub contributor list, but one guy, he actually spent a lot of time building out this templating engine, and it works really, really well. There's also a few other options on here that are not specified, but you can see the full list of supported tags. There's things like, hey, just put all of my arguments in here, whether they're free, positional options, whatever, stick them all right here. Before and after help, messages, all kinds of things. If you look at ripgrep is using templates because it wanted them in the doc-op style, but also in the doc-opt order that they're using before. So, all right, almost there. We're on to the advanced topics. Now, I say advanced topics, they're not really that advanced, but they can get a little bit confusing sometimes. So the first thing is conditionals. All of those relationships that we talked about before, whether it be a default value, requires, required, overrides, they can also be applied conditionally, meaning only apply these in certain conditions, whether another argument was used with a specific value or not. So you can do things like only have this argument required if other arguments were used with particular values. You can also say things like this argument should only be required if another particular argument was used with a particular value. One of the more interesting ones that I find, I don't know why, maybe it's me, is having different default values based off of what was used by the user. So again, if we look at this, I'm not going to go through it line by line, but these are a bunch of different, you can uncomment each of these and see what the default value of this other argument is based off of whether or not other arguments were used. So it's got a default value if flag was used, or a default value if sum was used with the value special. And it goes through each of those, and you can see, or if a user has provided value, it overrides everything and just gives you the user value. You can also set aliases. Aliases can apply to either arguments or to subcommands. And it's a really nice way to either migrate CLIs or just for pure user experience. If you guys have used rustup, I can't tell you how many times I've typed like rustup doc or rustup docs. I can't remember if there's an S or not. So just adding a hidden alias of doc and docs, your user types it and it just automatically gets it right, is kind of a really nice thing. You can also tell them whether or not you want it to clutter up the help message by using visible aliases, or you can say, no, a regular alias means it's not going to be shown in the help message, it's just going to work. Using an alias is no different than if the actual argument itself was used. So if we were to go into the run online, I'm not going to click on it this time, but you'll see all you're doing is you're checking for the actual argument name. You're never checking for the alias name. So you don't have to know, oh wait, was the alias used or was the real arg used? You just check for the real arg. Same thing with subcommands. You just check for the real subcommand name. And shell completions. Shell completions is another one of the really big features that a lot of people like. There's two different ways to generate completion scripts. You can generate them either at compile time or at runtime. And as of right now, or as of this writing, the 4 shells that are supported are Bash, ZSH, Fish, and PowerShell. So I'm going to show you how those work real quick. If you were to do it at compile time, you have to use a build script, which is not that difficult. Really, all you end up having to do is pull your application struct, that top-level application, out into another module or into another function. And then inside your cargo.toml, you say that you're using a build script, and you also have to add clap to your build dependencies. Inside your build script, the only other strange thing you have to do is use the shell, which is all the supported shells. Right now it's those 4 that I listed. And you have to include this one function so that you can actually build your CLI.
So it actually has to be build CLI?
No. No, so if you're using a build script, I mean, you can name your build script whatever you want, but...
The function in the CLI.rs,
Mm-hmm.
does that have to be actually called build CLI?
No, 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 no. It could be called anything you want. I just called it build CLI for the sake of argument. So really all it is so that you can call it and build your application. And that way you're not double typing things more than once. Because you're also going to, in your main, your source/main.rs, you're also going to include and then just use this exact same function to build your CLI.
Oh, like this the include there. I got
Yeah.
you. Okay.
So yeah, so you're including the whole file. After you do that, we're just looping through all the shells. The shell enum in clap has a variance function that just returns back all the different variants in a string form. And then it also supports, or it also implements the from string trait, which allows us to do the shell.parse, and then we can unwrap it because we're pulling it directly from the variants. There's no way it can fail. So we're giving it, we're saying generate completions. We have to specify a binary name or whatever our binary is going to be called because this is a build script, this is compile time. Clap doesn't know what the final binary is going to be called yet. It hasn't been run. So we're telling it it's going to be called myapp. It could be called anything you want. Then we call shell.parse, so we're just going through the different shells. And then we have to tell it where to spit out the shells to, or spit out the completion scripts to. In this case, we're saying spit them out to the environmental output directory. That's something that cargo does. Mm-hmm. Yeah. You can specify anywhere. You can specify, /home/me. But once you do this, whenever you compile it, it's going to build up your CLI and then spit out 4 completion scripts for you into that one directory. Compile time, it's nice to do this if you are, say, packaging a program to give to other people, and it's going to have maybe an install script that goes with it that installs these completions, or something like that if you're going to be actually packaging. If you're not doing that, then you can go the runtime route, which is what RustUp does. And all they do there is they have their regular CLI, but then they also have a subcommand called completions with a single positional argument, index 1, called shell. And it only takes the possible values of those shell variants. So this way they always stay up to date with all the shells. If we add another shell, they'll get that. And then saying it has to be used. Whenever they go into their actual parsing code, they call their get matches. And then they check to see if the completion subcommand was used. If it was, this is the weird part, they rebuild the CLI. Rebuilding the CLI takes nanoseconds, so it's not even for a huge CLI. It's not a performance hit, or not a significant performance hit. They rebuild the CLI only so that they have access to call the gen completions. They could have called this in a non-consuming way and then just reuse that, but because it's such a minimal, you're talking fractions of a fraction of a fraction of a second, it's not a big deal. Just rebuild the CLI. They then call give me the value of shell and do the from string conversion, parse it, and then unwrap it. Again, this is all safe because the argument was required, so it can't ever not have a value. And because they pulled the possible values from shell variants, it also can't fail to parse. So both of these unwraps are safe. They then use, instead of gen completions, which spits it out to a file, they use gen completions 2, which takes a write object. Here again, they give it a binary name. In this case, a demo. For RustUp, it's RustUp. The shell that they want to parse, which was this one right here, whatever the user happened to specify, and then they're just spitting it out to standard out. This allows the user to then redirect to someplace, wherever their completions are installed to a file, and have everything installed. If we look at this, some of the completion scripts, what they look like.
Could you zoom in a little bit?
Yes. All right, so Here we just have, this is just from the clap homepage. It's just a bunch of arguments and subcommands, just something to actually generate. And we have our completion subcommand just like demoed in the previous example. So here if we call demo completions bash, so as if that were what we ran on the command line, we're going to do exactly like we demoed. If we click run, this is what would be spit out to standard out. All of this. So it just spits out. It does the same thing for ZSH fish. If we were to pull up, I think, let's see if it actually works live. That's the ZSH completion script. It does the exact same thing. That's the fish completion script. So RipGrep, I believe, also uses this. There's a few of them, but that's one of the nice features is completion scripts.
How expressive are the scripts compared to what you're doing in Rust? Like, how much validation can the scripts do?
So you're actually able to determine quite a bit from all of the validation that you're putting in up front about the arguments. A lot of, not all of it, but a lot of that gets encoded into the completion script itself. It varies by shell. ZSH is slightly lacking behind Bash in some areas, but ahead in others. It totally depends on the shell. There's also areas where we could improve. But for example, if you were to do Bash and it knows that there's two values coming after that, it'll prompt you for two values, or it'll spit out the two dummy values for you to fill in. ZSH is nice because it spits out also the help text along with the script. And in fact, I think if we have, so RG, we have pattern. So for RipGrep, I already had the completion script already installed, but this is what it spits out if you do --. And it supports things like stacking as well, all the different variables. But yeah, so it also shows you the short and the long and different things. So but it totally depends by shell. We're able to encode a lot of that, but not quite all of it. So.
So related to that, from much earlier when you had like, here's a list of possible arguments for this thing.
Mm-hmm.
Are you able to generate a list of possible arguments at runtime?
What do you mean?
So like if I did git checkout, the list of possible arguments
For
on the repo that I'm in, what branch?
Oh, I see. So like running more like arbitrary code to, not yet. And in fact, that's an open issue, which I'll come to in some of the open issues. That is something that I'm actively looking into, is adding a way to add arbitrary Rust code to your completions. So for example, if I were to type, git clone and then tab, maybe I wanted to check my current repo or something. Whatever the case is, you can add some arbitrary Rust code into those completion scripts. As of right now, no though. Right now, it just does either a dummy value or lists out what known arguments are. But if you do have, if one of those is an actual argument that you've encoded at the beginning, that'll be spit out at least. So that's pretty much it. There is a ton we have not covered, and for the sake of time, I'm not going to cover them all. I'm just going to give you the wave tops of them. Like I said, there are some far less verbose ways to define arguments, such as the usage parser, which is much more akin to like your docopt style, where you can say something like -c -config file some help. This will imply a lot of those settings we've been setting previously, such as the short, the long, takes a value, the fact that it's an angled bracket, we're implying that it's required, and then the help text, things like that. We didn't really talk about the speed at all. Clap is pretty fast, so there's a bunch of benchmarks in the repository if you want to look at those. But we've even tested it up to handling, an entire home directory, which is one of the reasons why RipGrep started using it. If you're passing in 10,000 arguments that all need to be parsed really quickly, in microseconds, then Clap's able to do that. There's also the from YAML, which is mentioned on the new RustStation podcast. You can define all of these arguments in a YAML file, and then just tell Clap, hey, use this YAML file to build my application struct and all my subcommands and all my args. And that's a really nice way to kind of keep your Rust code clean, but yet still have all of the same options that you have when you're building it like normal.
That
It happens at runtime. So the YAML parser is slower than using the builder or the usage parser, but again, slower is kind of relative. It's slower, but it's also not very much. It's not that measurable. The one difference with the YAML parser is it's behind a feature flag. You have to compile clap with the YAML feature because it pulls in extra dependencies that not everyone may want. So.
So would you have to, if you're distributing your application, would you have to distribute the YAML as well?
No. So what actually happens is it pulls in that file at compile time and includes that file as a static string in your binary. So you can compile the binary still just by itself. It's just that particular string isn't parsed until runtime. And then there's a bunch of macros. There's the clap app macro, which is sort of a hybrid between this usage string style and the builder pattern. It's just as fast as the builder pattern, execution speed wise, but it's less verbose like the usage. There's a bunch of other shorthand syntax with the macro that you can use as well to shorten it up even more than the usage parser. So if you look at Habitat, one of the applications by Chef, they use the clap app macro very, very heavily. There's also a bunch of crate _ blank macros, such as like crate author, crate version, crate description, crate name. All of these things will pull the metadata from your cargo.toml. That way it stays in sync. That way your application struct stays in sync with whatever's in your actual cargo.toml, such as your version, your authors array, things like that. That way you don't have to worry about keeping those up to date. There's some value T macros that will just change the strings into actual values. You also have an arginum macro, which allows you to use enums as argument values. So if you want to, it just basically what it does is it automatically implements a bunch of the from string and a bunch of those other traits for you automatically. We didn't talk about any invalid UTF-8 handling because that gets more complex, but Clap fully supports invalid UTF-8. All of the value of or values of for the ArgMatches, you can request OS strings instead of just strings. Reason being, strings will panic if there's invalid UTF-8, which a lot of times when you're messing with paths and things on Linux, invalid UTF-8 is perfectly acceptable in those environments. So, but Clap allows you to handle all of those. Same thing with the validators. You can do OS string versions of validators. If you want to look through the documentation, anything with _OS appended to it means it supports invalid UTF-8. The one other thing you'll have to do with invalid UTF-8 is out of those app settings, there's one that says allow invalid UTF-8. You need to set that because otherwise Clap will warn you that hey, or it'll panic if you didn't specifically set that. There's a few optional cargo features. YAML was one of them. Another one of them is the suggestions, which is actually on by default. The suggestions is if you make a typo when you're typing out an argument, and it'll suggest something for you. So for example, with Rust up, we did completions. It'll say, hey, did you mean completions? So that's on by default, but you can turn it off. If for whatever reason you don't like that feature and you want to get rid of that one dependency, then you can turn that off. There's some other things like wrapping the help message. For example, with Rust up, if I were to make my terminal really small, these are all going to wrap and realign at the proper point right here. You can turn that on or off because that's another dependency, but it's on by default because most people would want it, assumingly. And color. You can see up here the error message. There's different colors in there. That's on by default. That's another feature you can turn off because it pulls in another dependency. As of right now, Windows does not support color, but that's an active issue open to add color to Windows as well. And then R groups. That was also mentioned in the New Station podcast. The R groups are a way to group a bunch of arguments into a single entity. That way you can speak about that entity in things like relationships, conflicts, overrides, without having to name every single argument in that one. You can just say, hey, all the arguments that belong to this one group, I need one of those arguments, to be specified because that whole group is required. But arg groups are a way to group like items. You can also do things with groups like, say, only one of this particular argument group can be used. I don't care which one it is, but only one and only one can be used. You can do things like that with arg groups. So we're still working on a bunch of things in Clap. The biggest issues right now are man page generation, just like we do the completion scripts. We're working on generating man pages. Automatic negation flags. The biggest one on this list is deserialization. So right now, one of the biggest pain points is you get your ArgMatches struct, but then to convert that to your args struct or your configuration, your God object, you have to go through and manually pull out like, hey, okay, this argument now becomes this type, whatever the case is, right? You go through and do that conversion manually. With the release of Rust 1.15 and macros 1.1, we can now do custom derive and derive that for you and just have it automatically spit out, so a la docopt. But we're working on the design of that right now. And that right now, if you look at PR or 835, that's the tracking PR for that particular issue.
So is that why the builder pattern there's no like get int or
Yeah. Very early on, I looked at doing that, but it was always kind of like, oh, we'll use a procedural macro for that, or whatever the case was, we kind of put it off. And then eventually macros 1.1 was on the horizon, so I was like, okay, well now we're just waiting for that. The custom Rust code for shell completions, that's issue 568. So if you're interested in that, that'd be a good one to follow. And then adding color support for Windows.
I was curious about the man page generation. What's the level of demand for that?
There's a few people that have been asking for it. Josh Triplett, if you've heard his name before, he's been asking for it pretty heavily. There's a few people that have kind of been like, hey, it would be really nice. Things like ripgrep are making the man pages manually or having them generated some other way. It'd be nice to be able to say, hey, generate all the completion scripts and all the man pages automatically. That way you don't have to worry. If you go back and change an argument or change a name to something, you don't have to go back and be like, oh man, where are the other 30 places I have to change this argument name? So.
Do you have like extended description? So for the Rails.
Mm-hmm. Yes.
You do the full, and you get a long description if you do
so,
help.
No, there is a way actually, as of right now, by default, no, there's not a way to do that. Okay, there's not a way to tell Clap to do that. You can do it. In fact, actually, if you pull up the ripgrep crate, he's doing exactly that. Basically, what he ends up doing is he uses a macro and says, hey, if someone calls -- help, display the full thing. If someone just calls -h, only display the short title or whatever. So I've looked at doing that automatically because it's something I could totally do. I just haven't added it yet. But yeah, I do like that a lot, and I think that's something we're going to add pretty soon. If you look at the Clap repository, there's a projects tab. If you click on that, it shows like different PR or like issue statuses. What I'm thinking of next, and that particular thing is actually in the up next queue. So. But yeah, there is a way to do it. It's just right now you have to do it yourself. All right, and that's pretty much it. But for this slide, absolutely thank you to Distil Networks, Integer32, Aaron Turon, and Burnt Sushi. So if you guys want to get involved in anything, there's an open issue that's been on This Week in Rust a few times. The Android RS Glue, the maintainer there was asking for somebody to convert their arguments over to Clap. So it'd be a good opening issue to try out. There's also the utils, core utils, which is all the Unix core utils ported over to Rust. Those maintainers have also said like, hey, we'd love to use Clap where we can. So that would be another good one. And then also just porting a CLI just for fun. That's something that actually helps me out a lot because I find out where the pain points are, what needs to be changed, where any bugs are, what can be improved, things like that. If you want to contact me or follow up with me, there's the clap.rs website. There's some YouTube videos out, argument parsing in Rust, that go over what we've been talking about, although in a little bit more detail. Not fully complete yet. I still need to add some more. Just time of day. Need more time. There's the Gitter for Clap. There's also the GitHub repo. You can follow me on Twitter. I don't tweet that much. When I do, it's usually Clap or Rust related. And then in IRC, I usually sit in those two channels. Usually go by KBNAP. That's pretty much it. So if you guys have any questions.
How long does it take you to build all this?
In its current state, it's probably been about 2 years now.
What was your motivation for building it?
My initial motivation was to learn Rust. So I was like, I really need a good project. And because in Python and Go, we use a lot of like just one-off scripts and little command line utilities, I was getting kind of fed up with some of the way those worked. So I was like, hey, you know what, to learn Rust, let me do an argument parser. There was DocOpt out and GitOps were the two that were out at the time. And I was like, oh, let me just see what I can come up with. So I started working on it, and it grew from there. So.
How many other major contributors are there?
So on and off, there's some people that will do like, there's a lot of drive-by contributions. There's a lot of major one-off contributions, like the help templating, where someone will come in and put like a lot of effort into a single area. And then as far as like major other contributors, there were 3 other ones besides myself at one point in time. Some of them have since dropped off, or they'll come back from time to time as work and time and school allows. As of right now, there are 2 guys working pretty heavily on the custom derive. And then there is 2 other contributors besides myself that kind of do just general triage management. And then there's a 3rd that was one of the original 4 who shows up from time to time as well. So all in all, like on and off, you have anywhere from myself to plus 7 or 8 guys, or 7 or 8 people. So.
What was the major pain point? Like, what was the worst section that you first designed to develop?
The thing that still kind of plagues me to this day is that it's being stringly typed. So that's an issue that I've even been burnt on myself. If you are putting in an argument name, let's say IP address, and you accidentally put an extra S in there, and then later on in your code you check for IP address spelled correctly like you should, Clap will tell you like, hey, there's no argument defined like this. I don't know what you're talking about. So that's the biggest pain point. With the custom derive, that helps a little bit. I came up with a few macros where you can use enums as keys, and in fact that was one of the open issues. Yep, 459. Came up with that a little while ago, but because 1.1 was kind of on the horizon and I was thinking about a 3x at that time, I was like, I didn't want to introduce some extra complexity that I was going to have to maintain and then also possibly just throw away at 3.0 anyways. So there is a way to use enum keys. In fact, you could even do it today if you derive asref string or string slice for an enum for all of the variants. You could use those as keys, and then at that point, a compiler will tell you, hey, there's no key, argument key by that name. But it just hasn't been added into mainline Clap yet. So that's the biggest pain point. As far as design decision, I go back and forth. I definitely like having a single arg struct to go with everything. But that definitely makes the internal workings harder, because internally you have to keep track of what's what and use different types here and there. So I've struggled with like, I just want to add one extra type in here that people will have to memorize and know when to use it. And then I'm like, no, that was the whole reason I created Clap in the first place, was that people didn't have to memorize. Like really all you should need is a completer and an editor. And you should be able to fumble your way and tab through building a functional CLI. And not just functional, but actually a pretty complicated one as well.
It's trying to learn all the verbiage and figure out
Yeah.
how it fits together.
I struggled a little bit with how I wanted to present. A lot of people are like, hey, can you tell me how it works with, versus DocOps? Like, how does it compare to these two, or to GitOps? And that's difficult because one, DocOpt is an awesome library, and 2, the maintainer is amazing. But also, they're different in their own right. DocOpt does some things great, like the deserialization into Rust types is super painless. That's awesome. So it's difficult to compare the two. But yeah, definitely the learning curve for some of those is one of the reasons why I created Clap. And then also, I forgot what I was going to say with the second point, but yeah, the learning curve was one of the main reasons that I created that. And yeah, and I'm 100% open to suggestions, issues. People ask me all the time, like, "Hey, man, can I ask a question on how to use this in the repo issues?" I'm like, "Absolutely, yeah." And in fact, usually if you have that question, other people have had that question too. So I'm absolutely open to suggestions, to questions. Usually when people request stuff, I try and add it if it's not a performance hit to everyone else. The only time where I'll kind of bulk is if it's going to either impact every user unknowingly, or if it's going to change some of the defaults. Anders submitted some stuff earlier. Unfortunately, that just happened to be one of the features that needed some major design. Totally unrelated to Anders. It was the getting values out of environmental variables instead of just from the command line, which is absolutely something I want to add. But it turned out there are some idiosyncrasies and edge cases to how that's handled that to this day we still haven't landed that. But I'm always open to help people out through PRs as well if they have questions like, "Hey, where do I even start with this? What files do I look at?" So.
Do you have DocOps, when I first saw DocOps, I was like, oh, that's a really obvious in retrospect, but like a really cool idea that hadn't been done yet.
Yeah.
And it's kind of like a theme of like, oh, this thing that you already should be generating, but often people don't.
Right.
You just work on that, and then we'll do the rest for you.
Right.
Do you have like an overriding kind of sort of theme at all that you're kind of using?
So the two themes that I've gone with are, one, I want it to be ultra configurable in the complex case, but in the easy case I want it to be dead simple. 2 lines of code and you're done. If that's all you need is 2 lines of code. So sort of the zero cost abstractions sort of thing, you can use as much or as little as you want. That's kind of been a guiding principle, along with that's probably been the guiding principle. I want it to be easy to use when you don't need all the features, but if you want to dive in and you want to dive in deep, you can make this thing your own. You can hot rod it all the way you want. And that brings up the other point when I was talking about DocOpt earlier. Speaking with Burn Sushi, he has a pretty good quote saying, "DocOpt is like a black box. You get what you get," sort of thing. And that was something I wanted to do with Clap, was like, hey, if you want to dig in and tune every last nut and bolt, you can. You can really tune this however you like, because that's one thing I've seen in a lot of different CLIs. As I've looked around, a lot of people will use the CLI to build out the arguments, and then they do all the validation and everything on their own, which gets messy. And it's easy to overlook things. There's edge cases, which I did not even know how many edge cases there were with argument parsing. It sounds like such a simple thing to do. And in fact, a lot of times I'll give a talk or something like argument parsing. That's ridiculously simple. Why are you even focusing on that? Turns out there's edge cases everywhere.
That's what I was asking about your motivation. I'm like, who sits down and doesn't want to write an argument?
Yeah, it was absolutely, it was purely to learn Rust. I was like, I want to learn Rust, and this is a project I'll work on. It was absolutely nothing more than that. But then some people started using it, and they're like, hey, I like this. Can I do this with this? Can I do that? And I was like, you know what? This is a little bit nicer than some of the stuff I've used in other languages. Let me put some actual time into this. Since then, it's grown on me, and I really do like working on it. But yeah, it's one of those things you totally don't think about up front. So, but yeah. So if there's no other questions, and if there are, feel free to hit me up after this later on. Yeah, you can contact me here. These slides will remain up. I don't have any plans to take them down. Same thing with the play links. I don't know how long the play links stay around. I don't know if there's a cleanup process. They've been around for at least, I don't know, a week or two, as long as I've been writing these slides. So feel free to go in and play around with those. And if you come up with any questions or anything, absolutely, let me know. So thank you guys.
Thank you.